So the next part of this is we're going to take these expressions and we're going to write them either as one single trig function or a single number. If I can give you a plan of attack, it would be this. If there's two terms like there are here, try to factor out a GCF. If you factor out a GCF, then that's definitely going to be the way to go. If you could not factor out a GCF, like number 2 has 3 different trig functions. If you cannot factor out a GCF, then try to write one of them to match the other. For example, on problem 2, tangent, what else? How do you get tangent? What do you divide to get tangent? Sine over cosine. Look, I already have a sine and a cosine. So in my head, I'm going to go that route to start simplifying these problems. Down at the bottom, it's off my screen, but 7 and 8. 7 is the most complicated problem on here. And I think just now I said that out loud, I think I'm going to make sure I do that one first. So on 7 and 8, you have to combine rational expressions, which is something you did in Algebra 2, is combining fractions with variables. So you are going to be pulling in a lot of Algebra 2 on this unit because we're solving, y'all. And that's what algebra is, it's solving. So with that being said, I am actually, we're going to save this for number 3. I'm going to for sure do that one on number 3. Let me back up to number 1 because number 1 and number 2 frame things very nicely for us. Okay, on number 1, we're wanting to write it as a single trig function. There is certainly a GCF there. So we're going to factor out cotangent x. So the first line of my work is going to look like this. Any questions on that? I took out cotangent, and that's what's left. Listen, anytime there's a trig function squared with a 1, 99.99999% of the time, it's one of these. And it is. It's this bottom one I kept choosing. Look, see this one? It moved over to the other side. And it matches that. So what's cosecant squared? Minus 1. Look at this property. What happens when that 1 moves over? What's the only thing left over here? That's right, it's cotangent. So look, let me show you what I'm talking about. So remember, I cut cheesecake. Oh, that's the number 1, y'all. See? That's going to move over to the other side. That matches this. Oh my goodness. Oh, here it is. Where is it? So we're going to replace, let's recopy what we factored out. Cotangent squared. It was just one of them. It's just one of them. And remember, this part right here equaled cotangent squared of x. And again, I'll say it, the more you start working with this stuff, the more you will realize it behaves just like variables. Y'all, what is x times x squared? What's x times x squared? X to the third, that's right. That's what this is going to be. This is our single trig function. But the exponent goes right behind the t, and then you put the x. So you had one of these times 2 of these, you had a total of 3.
So wasn't we working out problems like this and using?
On Monday? Nope. No, I said that on Tuesday. It's just over 2. Let's keep going. So on problem 2, let's look at problem 2. So on problem 2, I have tangent, I have sine, and I have cosine. I have 3 different trig functions. I cannot rewrite cosine to look like tangent. I cannot write sine to look like tangent, but I can rewrite tangent. What is tangent? So let's write sine of x over cosine of x. Okay, that was tangent. Remember, tangent was multiplied by sine x, so bring that down. Bring down the rest of the problem, write plus cosine x. Okay, it almost looks like it got more complicated, but it's progress because I only have 2 trig functions now instead of 3. And I can kind of clean this up. This is sine over cosine times sine. If I do this, remember, multiply straight across. Sine x times sine x is sine squared x over cosine x. Let me bring down the rest of the problem. That's a whole number cosine x. I'll just put it under 1 this one time in this example. I cannot move forward until I take 2 fraction bars and write in this 1 fraction bar. I have to find a common denominator. The common denominator is the only denominator there, so it's going to be cosine x. So I am going to multiply this fraction by that denominator. So go over there to the right side of the fraction and write cosine x over cosine x. Now, let's start cleaning it up. There's nothing I can do with this. I'm just going to recopy sine squared x over cosine x. But I can certainly clean up this part. This turns into this. Once you get a common denominator, you need to write it as a single fraction. So now, the next line of my work is going to be a single fraction with that common denominator. I'm running out of room. I'm going to do the best I can to squeeze it all in there. There's the denominator. What's the numerator? Sine squared x plus cosine squared x. Yes, thank you, Keely. I'm sorry, I accidentally wrote a 2. It's just cosine x. The denominator is just cosine x. It did not change. Let's put the 2 numerators together. And then, for us in pre-cal, 99.99999% of the time, if you have a trig function squared, it's probably one of these. It is. What's the numerator? What's sine squared plus cosine squared? A 1. It's a number. It's right there. We just proved it right there when I asked you guys for radians. So sine squared x plus cosine squared x. I'm going to show my work up here. I want to make sure you guys see everything. That equals 1. So I'm going to put what it equals. Because remember, we want this to look as simple as possible. Any questions on that? Still not done. You can even make this look better. You can rewrite that without a fraction bar at all. What's the reciprocal of cosine x? Secant. So when I flip this, the reciprocal of this is secant. So the cleanest answer, no fractions, no plus signs, is just secant x. That's number 2. We're just going to go in order. Let's take a look at number 3. Wait. Number 3 has secant in it. What is secant the reciprocal of? So secant times cosine, those are reciprocals. What's 1 over 3 times 3? 1. What's 4 over 5 times 5 over 4? 1. What's secant times cosine? 1. They just cancel. All right. So is there a way for me to at least write tangent only once? There is. Let's factor tangent squared out. So that's going to leave 1 minus sine squared x. And then, if you want to make sure you're on the right track, because one little thing will throw it off, guys, you can distribute this back and make sure you get what was on printed next to number 4. Make sure you check and make sure you factored correctly, because it'll just be a downhill spiral with everything wrong. One more time. Anytime you see a trig function squared, especially with a 1, 99.99999% of the time, it's one of these. And what is in parentheses here is one of these. What is 1 minus sine squared x? Cosine squared x. This moved over. That's why it's 1 minus sine squared x. That moved over there. Remember, when stuff moves back and forth on an equal sign, the sign changes. So, this is going to be okay. Progress has been made, for sure. We don't have a plus sign anymore. Definitely going in the right direction. Now, can you write cosine with a tangent in it? No. Can you write a tangent with a cosine in it? Let's see what happens when we do that. So let's rewrite tangent squared. Remember, tangent squared is sine squared x divided by cosine squared x. Bring down what we simplified in parentheses. Y'all, we're done. What cancels out? The cosines cancel out. That's right. Remember, this is like over 1. Cancel. Cancel. Number 5. Y'all, number 5 are two of those identities right now. The numerator is one of those. The denominator is already one of those. Rewrite it. Look at the numerator. What's the only one that has sign in it, the top one? Yeah, it's cosine squared x. What's the denominator? Yeah, cotangent. So we're still in a dilemma because they're still different trig functions, but we lost the minus signs. At least we don't have the minus signs anymore. So it's not the final answer, but you're making progress. I cannot rewrite cosine with the word tangent in it. But I can rewrite, yep, I can rewrite cotangent. How can I rewrite cotangent? cosine squared x over sine squared x. There you go. Ooh, that is so ugly. Rewrite that. I'm going to rewrite it the long way, like in elementary school with the division symbol. So it's going to be cosine squared x divided by cosine x squared over sine x squared. Okay, what's next? Keep, change, flip. Yes. I seriously don't see how y'all fit this on the packet. I really don't. I'm going to have to work this over here. Keep, change, flip. And look at that. Again, what cancels out? What cancels out here? Yeah. Yeah. It is. So remember, numbers 4 and 5 had the same answer. Don't have any room. So let me rewrite this right here. All right. So, I have 3 different trig functions. Okay. This cosecant. This is 1 over sine x. So I don't know what I'm doing right now. I'm planning. Like, I can't just look at this and see what's going on. I'm not going to mess with cosine because that's like a foundation thing. And cotangent is cosine over sine. And you know what? This is a good plan. I like this. I was just kind of brainstorming, and I like what I wrote because I went from 3 different trig functions to just 2. I'm going to keep going. I'm going to clean this up, see what happens. So 1 over sine x. Remember, cosine times cosine is cosine squared x. Look. This is turning out quite nicely. I already have a common denominator. Remember, once you get a common denominator, your next step is to write a single fraction bar. Rewrite that common denominator one time. 1 minus cosine squared x. That numerator equals 1 trig function. Look at this and look over there. What is 1 minus cosine squared x equal? Sine squared x. And remember, y'all, these behave just like exponents. What would x squared over x simplify to? An x, yes. Then sine squared x over sine x is just sine x. All right, let's keep going. Number 7. Wipe your eyes, wipe the drool. You've got to be awake on this one. Here we go. All right. So, I've got secant and I have tangent. Chances are, look, secant and tangent are together. I'm going to keep this in the back of my head. I probably will use it. I don't know yet. None of them are squared yet, so I don't know. I'm just kind of thinking right now. I cannot rewrite tangent like a secant. I cannot rewrite a secant like a tangent. So you have to add the fractions and then analyze it. So we're going to take this and we're going to multiply this fraction by that denominator. Then we're going to take the first fraction and we're going to multiply it by that denominator. And y'all, I'm going to put this in parentheses because the whole thing was down there, and I don't want to lose anything. When you get to this point, just stick the denominators together. Don't multiply out the denominators. Do not multiply out the denominators ever. You save that as absolute last resort. But do multiply and combine like terms in the numerator. You do have to do that. So let me go ahead and distribute. So secant times 1 is secant x. Secant x times secant x is secant x squared. And remember, a positive times a positive is positive, so write a plus sign. Okay, let's go over here to this side. Y'all, don't forget that tangent x is negative. So negative tangent x times tangent x. What's a positive times a negative? Yes, so write negative tangent squared x. There is a substitution there. And it is right here. Y'all, that's this. That tangent's over here. It's negative. So what are those parentheses equal? That's right. So it's going to be secant x plus 1 on the top over that denominator They do, but look, this isn't, I want everybody to know this. Where's this? Is what I was saying. Look, if that had anything else with it, it would not cancel. If there was anything else up there, it wouldn't cancel. But nothing else is up there. So it does cancel. So that's going to be 1 over tangent x, but we're not writing that. We can write that without a fraction. What is that? Cotangent x. That is correct.